number 7. This is paper number 1, problem number 7, and you are asked to find the area of the curve. Arctangent is going to look like this, and we're looking at arctangent down to the x-axis and then to x equal the square root of 3. And so we're looking for this area in here. And that's not very hard to set up. It's just going to be the area going from 0 to the square root of 3 of the function arctan x. Any problems with that so far? Just the setup is no big deal. But the question is, how do you evaluate it? Well, the first thing you got to do is recognize the technique that you're going to have to use. And what technique is that?
By parts.
It is by parts. This technique to evaluate is going to be by parts because if you do liate, up is u and dv is down. I would say that what you're looking at, arctangent, that's an inverse arctangent. What's dx going to be? Algebra. That's going to be your dx. So my dv, normally we want our x's to go down by taking derivatives, but this is the opposite. It's kind of counterintuitive. You're going to have your dx here, and you're going to put your arctangent x here. So here's your u dv. So let's operate that to get du. I want purple here. Du, what's the derivative of arctangent? 1 over 1 plus x squared. Yep, and it's in your packet. But hey, we want to memorize as many of these as we can. If you go to my multiple choice Schoology practice quizzes, you can find this one on the derivatives of trig functions. What's the antiderivative of dx? X. So crazy X marks the spot. Yeah?
You're putting that square as your work in an IB test. Do they recognize that?
That's a great question. It's they're going to recognize you're performing an integration by parts, and then when you do the next step, this is probably where they'll give you your mark. Is when you go x arctangent of x minus antiderivative of x over 1 plus x squared. That would be a mark. This is how you organized it. Doesn't probably warrant a mark, but that will. That's a great question. Yeah. So now you got to evaluate this one. So how are you going to do that? How are you going to find the integration of this? Well, I'm going to let u equal to 1 plus x squared, and the du is going to be 2x dx. And I do have the x dx. What don't I have? The 2. So we're going to put that in there. 2, 1/2. So this will become x arctangent of x minus the antiderivative 1/2 du over u. What's that? Natural log of u. So I'm going to go minus 1/2 ln of u. And u is 1 plus x squared. Going from 0 to the square root of 3. How are we doing so far? You feel good about that? Okay. Now we just have to evaluate this. So you're going to put the values in, and I'll just plunk those in. Put the square root of 3 in first. Square root of 3 arctangent of the square root of 3 minus 1/2 natural log of 1 plus root of 3 squared is 3. So this is just going to turn into 4. That minus, well, if I put a 0 in for x, that's just going to be 0. And what's the natural log of 1 plus 0? What's the natural log of 1? 0. So that whole thing goes to 0, and so you'll be left with the square root of 3. This is worth 1 mark. What's the arctangent of the square root of 3 without a calculator? It's either pi over 6 or pi over 3. Pi over 3. It's pi over 3. Here's how you know it. Here's the unit circle. Here's how you know it. Okay? This coordinate here is going to be 1/2 square root of 3 over 2. This one here is going to be square root of 3 over 2, 1/2. Now when you do a tangent, you go y over x. So this y over this x, what's square root of 3 over 2 over 1/2 going to be? Square root of 3. So there's your pi over 3, and then this is 1 over the square root of 3 is what this one's going to be. That's your pi over 6. Which is bigger, 1 over square root of 3 or square root of 3? Square root of 3 is bigger, so that's, I remember it this way. It's going to match with the pi over 3, the bigger of the two. But you can always figure it out if you needed to. All right, so now that you have that, now what you're going to do is you're going to go pi over 3 minus, now this is the natural log of 4 to the 1/2, because I can move this up power, and that's worth a mark. Natural log of 4 to the 1/2, what's square root of 4? Done. There's your answer. That's what they're looking for number 7, without a calculator. For you.